Hi, so we've been looking at the Dumas effect in the previous two videos, and I'll put a link at the end of this video, so if you want to jump onto those and have a look, then by all means do. But there have been some great comments that have been really wide-ranging, and so interesting that a couple of line answer really is more, it's not what they deserve much more than that. But I can't write a missile for every comment that's been made, so I don't intend to. What I thought I'd do is this video. Now, there does seem a tendency in people that when they discover something, they love it to be named after themselves, and this is a great example. We've got the Dumas effect, the Davy effect, the Weissman effect, all on the same effect from people who have independently discovered this particular effect. And of course, they haven't really discovered it. I mean, it's been pointed out that this is in fact just a stinger, which is exactly what it is. It's been used for 100 years or something. I think it began in sort of World War II or so. So it's a very long described effect that's been in existence and been known about for everybody who's been in prison and made their own hooch. It's an awfully well-known thing. The only thing that surprises me is that Dumas got a patent on it. But then the patent office is renowned for this sort of stuff. But people will argue that no, it's not just this application of AC, it's the resonant frequency of water. Well, I hate to say this, but to my mind that's extremely unlikely. Now, the idea of resonance is, it's like pushing a swing. If you can get it to swing all by itself, of course, we know it takes very little push to keep that momentum of a swing going, because the swing is in resonance. Now, the idea is that the water molecule will be stretched and squeezed and stretched and squeezed in resonance, and so it vibrates and, like glass, will break itself apart. So that's the essence of this resonant idea, and the Dumas effect is supposed to contain that. It's not just a stinger, it's specific to the shape, and so we get resonance set up. Now, that may or may not be so, but the resonant frequency of water is somewhere around about 22 gigahertz. It's actually a bit more than that. Whereas, of course, the frequency we're applying is 50 to 60 hertz. So, to my mind, it's extremely unlikely that a resonant effect is actually having anything to do with it at all. Now, there is a commercial product based on this that's been developed by a company called HeatWorks. If you put HeatWorks ohmic heater into your Google search bar, you'll find the company. It comes up first, and they have a ton of information on the stuff that they've been doing, and they've been using flat graphite plates, which is exactly why we use flat graphite plates. And it's supposed to be an ohmic heater, which I can understand. It's an ohmic heater where the water is acting as the heating element, rather than having a heating element. Heating elements have their own associated problems. You have to isolate them from the water because it's connected to the mains and has a plus and a negative. And of course you do that with magnesium oxide and a metal shell, and that takes time to heat up, and then you're boiling the water off the surface. So when the water boils off the surface, it deposits salt and you get limescale build-up. So all of that stuff is what goes on in a standard electric heater. The claim is with this ohmic heating, where you're heating the water, because you're not heating on the surface of the plate, you don't get salt deposition. Because you don't get salt deposition, you don't get limescale build-up. Because you don't get limescale build-up, you don't get reductions in efficiency, and so the thing is much more efficient. Don't blame me, that's the claim. Look at HeatWorks. Now, a number of people have been suggesting that this is very strongly related to the HHO cell, which it is. The difference is the HHO cell uses DC. When you're using DC, you're entering the world of electrolysis, which is exactly what the HHO cell does. It electrolyzes the water into hydrogen and oxygen. But electrolysis needs three things. It needs two plates, it needs an electrolyte, which is a conductive solution, and it needs a direct current. Now, it's Michael Faraday who coined the term electrolysis, but it was Humphrey Davy who actually started to look at it and recognize the fact that chemical reactions involve the exchange of electrons. And of course, a DC current is a flow of electrons as long as it has a path to flow along, which is why you need an electrolyte. An electrolyte is a conducting solution. It must conduct, and so it contains salts. As that current flows from positive to negative, then the ions in the electrolyte are attracted to the opposite charged plates. So all the negative ions go to the positive plate, all the positive ions go to the negative plate. And if you perform electrolysis, like metal plating an object, for instance, you'll see it's actually quite a slow process, and you'll see the deposition of metal on one side and the release of the other material on the other side. And that's what electrolysis is. Now, electrolysis, as I say, is in electrochemical terms relatively slow. So if we apply DC to water, then the water will split into hydrogen and oxygen, and you can see that gas being released. That's electrolysis. When you use an alternate current, of course, what you're doing is you're swapping the plus and the minus. So like we say, we've got an ion sitting in there, a little positive ion. This side's negative, it's going to be attracted to it. Then we change it to this side negative and it goes that way. So all that happens is the ion moves a little bit backwards and forwards, and the distance it moves is related to the frequency. So the higher the frequency, the more often you change the positive and minus, that little ion just jiggles around in between. The lower the frequency, the more distance it can move, and so it can get to the plate, which is why you need DC. Now, of course, when you turn an alternate current on, for that 1/50th of a second, you have a plate which has a charge on it, and there is liquid touching that plate. So a very, very small amount of ions sitting on that plate will be transformed into gas. Yeah. But it is a well-known phenomenon in flow batteries and in water electrolysis that when you first create the gas sticks to the plate. It's actually such a problem you have to vibrate it to get the gas out and stop it from reducing the electrolysis, because of course when the gas is on the surface there is no contact with the liquid and there is no electrolysis that goes on because there's no contact. So you have to get the gas off, and that actually takes a surprising amount of time. Now, water itself contains dissolved gases. So gas will dissolve in water and it will stick to the plate, and it has 1/50th of a second to become gas, and then the plate reverses its current and the electron it just donated, it grabs straight back again, and this gas becomes an ion. So although an almost insignificant amount of electrolysis will take place in alternating current, it is so insignificant and the gas has such a propensity to dissolve or stick to the plates, of the overall cell, what you get is nothing at all. And so you don't get any electrolysis when what you're doing is applying an alternate current. So in a strict sense you do right at the surface, but in an overall sense you'll see nothing at all, because it will reverse its polarity and anything that's been donated will be grabbed straight back off again. So electrolysis in a broad sense can't happen with AC, it only happens with DC. You must have that flow of electrons from one side to the other to separate the ions, give them time to give up or grab their extra electrons and deposit themselves, and it's a lot longer than 1/50th of a second. If you reduce the frequency, of course you're going to get more electrolysis. We know that because all DC is AC at no frequency. So if we take it down to 0 hertz, we get DC and we get electrolysis. If we take it up in frequency, then the amount of electrolysis that we get drops down quite remarkably until we get to a frequency where there is no overall electrolysis. As we increase the frequency, then there is less and less and less of this that happens. But that only happens at the surface of the plate. When you look at the cell and you apply AC, you will see no electrolysis and no gas being given off, however much you wish it to be. Now it also happens because, remember, water dissociates naturally into H plus OH minus. So even distilled water has a very, very, very low conductivity or an extremely high resistivity. But it does conduct a tiny, tiny bit in an absolute sense. But in a practical sense, no. So you can argue that electrolysis happens if you want, but it won't do you any good because you can't do anything with it. That's the problem. So just to reiterate quickly, the Dumas effect is down to ohmic heating, which is all by itself quite efficient because the water itself is the resistive element, or at least that's the claim. Resonance is extremely unlikely to play any part whatsoever because the natural resonance of water is 22 plus gigahertz and the frequency we're applying is 50 hertz. electrolysis just won't happen as you look at it on the large scale. So there's no problem with hydrogen and oxygen evolution. Anyway, I hope that explains the Dumas effect. What I'm smiling at is I can just imagine the comments on this one where people are going to go, oh no, it's just a water heater, don't bother. It is distinctly different to have a wire heating something and to have it directly heated all by itself. So certainly that's what I find interesting about the technology, because it leads to tankless heaters. If you want to know more, do look up Heatworks. I'm not being paid by them to say this. I think it's really quite interesting and well worth a look at. Anyway, I hope you enjoyed the video. I do sincerely hope it helped with some of the comments. Thank you very much for watching, and please do remember to like and subscribe.